Oh, it's Reese's birthday.
Yeah, it's Reese's birthday.
We sing
Yeah.
happy birthday.
No, we're not going to sing happy birthday.
Why not?
Happy birthday, Regis!
I knew it was his birthday because his girlfriend posted on Instagram. It's not even that.
Okay. So we're going to start off today with something really easy, relations and functions. You should all know this. Those of you that did take the Keystone will probably remember seeing function stuff like a lot. Okay, so those of you that are going to be taking it, this is heavily on there. It's not hard, but it's on there. So the first vocab word is a relation. Everyone always forgets about the relation because they focus on a function, but a relation is just a set of ordered pairs. That's all it is. So here's an example. Ordered pairs relation. Example 1, graph the following relation. Remember seeing these on your summer packet? Some of you played connect the dots. Don't do that. Just plot them. That's it. Relation, just like almost like a scatter plot. What's the domain?
X.
Yes, it's the set of all x values. You can also call those the input values or the independent variable. The range is the set of all y values. We will do a lot with domain and range this year. Right now we're just doing them ordered pairs, but eventually we'll get to do like the domain and range of a piecewise function. Something like that. So we'll see holes in the graphs and stuff. It'll be fun. It'll be fun. Okay. Find the domain and range of the following relations. So for the domain, we are going to list it in the set notation, which is like a brace. Some of you are going to be really bad at drawing it. Just do your best. The domain is our x value, so that's 11, 12, 13, and 20. We will list them in order from least to greatest, and we don't repeat any of the numbers if they would repeat. The range is the set of all y values. Now, if you notice, we have -2, -1, -2 repeats, so I'm not going to write it another time, and 7. Okay, so even though there are 4 points. These are called braces. They contain sets. So when you're listing a set of x values, they're set notation. All right, now this one has ordered pairs. So some students like to go and next to each point they want to label it. That's fine if you want. -3, 2, and do all of that. Or if you don't want to do that, you can just look at the graph, which is what I like to do. So for domain, I would start on the x-axis, and I would start at the negative and move my way over. So I see there's a point at -3. Keep going. There's a point at 0. There's a point at 2. And there's a point at 4. Again, if you're watching on the board and you're like, what? Just write down all the ordered pairs.
Does that have to be in order?
They should be.
Basically true.
They should be, yes. So again, if you don't follow, just do all the ordered pairs and then just look at the x's and the y's. But if you like what I was talking about with just looking graphically, you look at the range, you start on the bottom of the y-axis and just rise up and see if there's any points that fall on this horizontal line. So there is one at -3. There's one at 1, 2, and 4. Okay. Next up, we have mapping diagrams, which are where you take the domain and range and you put them in a picture. And you actually, it's called a mapping diagram because you'll connect the element in the domain to its matching element in the range. Okay? So again, mapping diagram will link elements of the domain to the values of the range. And then function. On the Keystone, they love to ask, is this a function? Yes or no? So a function is a relation in which each element of the domain is paired with exactly one element of the range. Okay, the shortcut way to remember this is that the x value cannot repeat if you're looking at like a set of ordered pairs. So for example, the function 2x plus 1. I don't know if you have this picture or not. Probably not, just look. So pick a number, plug it in. Let's say 5. So x is 5. I plug 5 into my function. 2 times 5 is 10. 10 plus 1 is 11. So my input was 5. My output was 11. That would be like an ordered pair. 5 from 11. Okay? That's what a function should do. When you put one number in, you get one number out. Now, to give you an example of something that's not a function, the square root of x. If I plug 4 in, what is the square root of 4? Technically. Josh?
Plus or minus
Good. Positive and negative 2. This would not be a function. Bless you. When you put one number in, you're getting 2 different numbers out. Okay, so that would be an example of something that's not a function. All right, so down here they want us to create a mapping diagram to model the relations. When you create a mapping diagram, again, you're going to do the numbers in order from least to greatest. No repeats. And you do have to connect the x value to its matching y value. So these are the same ones we did above. So 11, 12, 13, and 20. Negative 2, negative 1, and 7. Again, you don't double count that negative 2. You don't write it twice. And I just remember on the quiz and test for this unit last year, a lot of students forget to draw the bars, and I took off points and they complained to me. A mapping diagram, again, has to link one to the other. So you link 11 to negative 2. You could put a line, segment, or you could put an arrow in it. If we're talking about geometry, we could put a ray. Right? So 12 goes to negative 1. 13 also goes to negative 2. And 20 goes to 7. So you have to have those connectors. And then they ask us, is it a function or not? So do we think this is a function? For every one number I plug in, do I get just one number out? Yes. When you're testing the function, remember, you only want to look at the domain. Make sure there's one line coming from each of those. Some students focus too much on the range, and they think, oh, well, 2 of those are pointing at negative 2, so it's not a function. The range is irrelevant in terms of the function. You're just looking at the domain. Okay? For every one input, you get exactly one output. All right, do the next one. We have negative 2, negative 1, negative 2 repeats. Negative 1, 0, 1, and 3. And then again, we just connect the x value to its matching y value. This one we should see is not a function. And again, the main reason is from negative 2, there are 2 numbers that are associated with that. You can just look at this list, and as soon as I saw that the x value repeated, you would know it's not a function. Okay, but because the question asked me to complete a mapping diagram, you had to do that part too. Okay. See if you guys can try the next example. There's 4 of them, just identifying yes or no for the function. So take a minute to answer yes or no for those. What do we get for A? Yes or no? Shout it out.
Yes.
Yes. B?
No.
No.
Yes.
This was Y. C?
Yes.
Yes. And D? No. Very good. The reason for this one was our 0 repeated there. And the x value. Awesome. All right. The other way that you can test if something is a function is by analyzing the graph. So another method to determine whether a relation is a function is to analyze, which means to look at and think about the graph using what's called the vertical line test. You remember this? Yeah. Okay. So the relation is a function if a vertical line passes through only one point at a time. The relation is not a function if the vertical line passes through more than one point at a time. And just remember, horizontal goes this way and vertical goes this way. If you ever see me say VLT, that stands for vertical line test. I don't think I do a lot in Algebra 2, not for what I So you would technically draw like a lot of them, which right here, these would all pass, but you have to keep going and test all of the points. You can see that it fails here because it hits 3 points. So this would not be a function. This one is an absolute value graph. You can see that no matter how many vertical lines you draw, that's always going to intersect at just 1 point. So that would be a yes. See if you guys can try those 3. All right. A? No. Good. B? C? It is a no. So it fails right there because it hits 2 points, and it also fails right there. But it only has to fail 1 time for it to fail. Last thing we'll look at are function rules. So the only difference between an equation and a function is the way that they write it. So you'll see this f parenthesis of x. Okay, that's not f times x. It means a function of x. Okay, so I'll do the same one I did on the front. It's like the same thing. Okay, on the test, there was a problem where it said something like negative x squared, I don't know, plus 2x or something, and it said evaluate for when x is negative 2, and we plugged negative 2. I think it was negative 3 on the test.
Negative 3.
Okay, something like that. The same thing is showing up today, but instead of seeing it that way, it'll just say what is f of negative 2 instead of saying x equals negative 2. All it means is you plug it in and then you do order of operations. All right.
Write that as well, or we can count that as
If it's given in function notation, you'll want to leave it as function notation. Okay, later this year, we're actually going to be performing operations with functions. We'll be putting functions inside of other functions, like that. So we'll be taking h of x and putting it into g of x, and then taking whatever we get there and putting it into f of x, and then we'll evaluate it finally. So, not right away. We'll work up to it, don't worry. Okay, we're going to do these without a calculator, though. We want to find 3 different evaluations. We're going to do negative 3, 0, and 5. So when we find f of negative 3, all I'm doing is plugging in negative 3. Some of you struggle without a calculator to do your order of operations, and some of you aren't using parentheses, and it's causing you to get the wrong answer. So 3 times negative 3 is negative 9, and negative 9 minus 5 would get me negative 14. Okay. We also have to plug in 0, so we'll do f of 0. This one we could probably do in our head. 3 times 0 is 0, minus 5 is negative 5. And lastly, they want us to plug in 5. So 3 times 5 is 15. 15 minus 5 is 10. All right, I'd like you guys to do B and C with the fraction ones.
You can write out like that, 0 times.
You should show the substitution in, so I'd like to see at least the substitution in the final answer, like I did here, Jax. So at least this and that for work. But for some of these, you need to find a common denominator. Well, not with 0, I guess. No calculator.